Exercise 6i applications. This is the last exercise in circular functions and it's all about modelling. So basically what we do here is we use sine and cosine graphs to model real life situations. When we are modelling, it's really important to take a good look at the question and ensure we look for clues within that question. When we provide answers, preferably give a written response and ensure that the graphs are sketched over the appropriate domain. So we look at the domain that's given in the question and make sure that what we've provided as an answer is relevant to what has been stated in the question. Alright, let's look at the question, or a question. While out on his trawler, John North, a fisherman, notes that the height of the tide in the harbour can be found by using the equation h is equal to 5 plus 2 cos of pi on 6 times t, where h is the height of the tide in metres and t is the number of hours after midnight. A. What is the height of the tide and when does this occur in the first 24 hours? Well, we can see here in the equation that our median is 5 and that our amplitude is 2. So the maximum height is simply going to be 5 plus 2. The median is going to be 5 and the minimum value is going to be 5 minus 2. So that's going to give us 3. We also notice that the maximum value for a cosine graph is always going to be at t equaling 0 so long as there is no horizontal translation. So here you can see that there is no horizontal translation, so the maximum is going to occur at the very beginning of the cycle, so it's going to occur where t is equal to 0, so in other words at midnight. So A, our maximum is median plus amplitude, so we end up with 7 metres, and I should have also stated there that this would occur first of all at midnight. B, what is the difference in height between the high and low tides? So the minimum, as I stated before, is simply the median minus the amplitude, so we end up with 3 metres. And the difference there is simply going to be 4 metres, so 7 take away 3. In part C, we need to sketch the graph of h between 0 and 24. You can see I have produced the sketch, but I've based this on CAS. So let's take a look at our CAS calculator. You can see I'm ready to do something on my CAS. I'm going to add a graph. So there's my graph, and now I'm going to put in the actual equation. So it's going to be 5 plus 2 times cosine of pi on 6 times, now instead of using t, I'm going to be using x here on my CAS. The other thing I'm going to do is I'm going to put in a domain restriction. So I want x to be between 0 and 24. So the time is between 0 and 24. So I'm going to put in a given that symbol. So I've just moved the cursor to the outside the function. And now I use control equals. And over here on the right hand side you can see that's the given that symbol. So it's given that x is going to be between 0 and 24. And then hit enter. Okay, so you can see the start of my graph. My window settings aren't right here. I know that I'm going up to a maximum of 7 and I know that I should be between 0 and 24. So let's take a look at our window settings. So menu, window settings. And I want the x, I don't really need to go to negative 10. I'm just going to start off at negative 2. I want to go up to 24, so I'm going to put in 26 here just to show plenty of space. The minimum value, I know that my low tide is at 3, but let's start at negative 2 anyway. And I know that my maximum, my high tide is going to be 7 metres, but I'm going to put in 10 here and go OK. Alright, so you can see the graph, and I'll just move this away a little bit. So just grab that out the way. And there's my graph, and it's shown between 0 and 24. So that's my sketch. Going back to the question, part D, John North knows that his trawler needs a depth of at least 6 metres to enter the harbour. Between what hours is he able to bring his boat back into the harbour? So what I'm going to do is on my graph, I'm going to put another line across and along here for where we have a height of 6 meters. And then I'm going to find where the two graphs intersect. So if I just bring up another graph, and it's just simply going to be 6 meters, so 6, and hit enter. And I know that it's safe to be in this region where the peak is here and over there. But the question is asking us between what times. So I don't really know where they intersect. But what I'm going to do is go to menu, and then I'm going to go to geometry, points and lines, and then intersection points. I now take my cursor, I move it over the first graph, select it, and then move it over the second graph, select that, and job done. To make it really clear, I can just grab some of these labels and just move them so you can read them easily. Alright, so basically, as you can see, it's between 0 and 2, it's between 10 and 14, and it's between 22 and 24. So they are the times where it is safe, where we have a clearance of above 6 meters. So looking at how I responded to that, so there's B. D, you can see here simply stated midnight to 2 a.m., 10 a.m. to 2 p.m., 10 p.m. to midnight. And there's, from my notes, just exactly what took place and handwritten explanation of the steps that you followed in your case calculator, but you've seen that already. So, that's modelling.